Hello, I'm scrambling to get ready. All right. Um, it's entirely possible that I forgot to put a link to my YouTube channel on my calendar. But hopefully people show up, and hopefully people can find this, even if they can't show up to it, since it's just on my YouTube channel. Yeah, I know it's 7 o'clock. All right. Ugh. Oh, I did put a link. Oh, sick. All right, thanks, Alex. And thanks, Nicole. All right, I was going to head and do the quizzes first, not least of which because there were some sections people did pretty crappy on. Oh, I didn't. Wait, what? No, okay. I'm going to call that trolling. So looking at our quiz averages, we see that second period got absolutely shellacked by every other period for averages. That was kind of sad. We are not going to be taking the trig section again because that is an A average, ladies and gentlemen. So that is very exciting. We're going to be taking 9, 11, and 12 next time because people did really well. Yes, and fourth period is first place. So that's pretty cool. And everybody knew how to graph except period 2, for the most part. Is there a certain pattern you use when graphing derivatives? Yes, and I'm going to kind of go through a few of them. Because I'm going to go through both quizzes. Both of the quizzes had different graphing derivatives problems. So it would be worthwhile to do. Alright, so to go to the quiz here. How did I do this last time? Oh man. I think I did it like this. And then like screen sketch. Cool. So for graphing derivatives, the first thing you do is when given a continuous graph, you try to look for any maxes or mins. This graph didn't really have any maxes or mins. So that was not where we went first with this one. So what we had to do this time is look and see that this is a negative slope, but it's getting more and more negative, steeper and steeper as you go farther and farther to the right. So we start out with a really small negative slope, and we get steeper and steeper. And so it was kind of following the graph at that point. On the other side, we have a really steep negative slope here. We're going down as we go from left to right. We end up going to not very steep here, and back to steep negative down here. So I start at steep negative, I go to not very steep, and I go back to steep negative. And then on our last bit, we have steep negative. We get to less steep negative as we go down here. So we're going to start at really steep and go over. So I have nothing on the upper part of my graph because the derivative is never positive. We are never increasing in this graph. So I saw a lot of very creative drawings on this one as I was grading it that didn't look a whole lot like this. In our second one, this is a piecewise. These generally are handled a little differently. Any of our straight lines are very easy to deal with. A flat line always has a zero slope because it's flat, zero slope. And then our parabolas always have lines as their derivatives. So we see that we start off with a negative slope, we have a zero slope here, and then we switch up to positive slopes. So I'm going to erase those now because yeah. Alright, so what I have to do is I have to go down and say, hey, that's about a -1 slope, so I'm going to make a dot there. And then up here I end up at maybe a, I don't know, 3 slope or something like that. And I just connect those with a line because the derivative of our parabola is a line. And there was a hole here, so you're supposed to put a hole there also. I was not as stringent about that. Now this guy just has a -1 slope for its whole time, so all I do is put an open dot at -1 and stay that way. And that was that one. So now I'm gonna pop back and see if that's what people were expecting. Eric's dad is in the house? Whoa. Can you do the other quiz? I absolutely will. The lag time's been reduced? Oh, sick. Alright. Alright, I'll go and graph the other one right now. That seems worthwhile. So if I go to quiz B and go to screen sketch. In this one, our picture was quite a bit different. Our continuous one on the right is absolutely one where we're going to mark off all of the zero spots. But our one on the left is similar to the one on the left in the other quiz in that there are really no zero slopes, no maximums or minimums that are obvious here. So it actually starts off really similar because this is a not very negative slope that gets more and more and more negative as we go down. So I start off not very negative and I just go down, because it gets more and more steeply negative, so our derivative value gets lower and lower, more and more negative. On this side, we have, again, a really negative slope that kind of gets close to leveling out. We end up at like a half a slope or so. So we end up like here, and we're diving down that way. Now, this was kind of the hardest stretch for a lot of folks between 1 and 2 here. We start off with a really steep positive slope between like 1 and 1.2 or so. So I started off like pretty high, like, I don't know, 4-ish, 5-ish maybe is accurate. And then we're just getting less and less and less steep. And because it kind of looks parabolic, I made that kind of straight. And for our last bit, we start off with a reasonably steep negative slope. And we're getting less and less and less and less negative. Alright, for the other one, this is like a truly continuous graph. All we do is we go to all of the maxes and mins and mark off our zeros. So there's a min, mark off a 0. There's a min, mark off a 0. A min, there, mark off a 0. Or max, whatever. Here we have a positive slope. So all you need to do in these continuous ones is if it's positive slope anywhere on this side of the 0, we just dive down from the positive side. You can see it's steeper and steeper down in the negative part of this than it is up at the top. Maybe it should look more like this if I was drawing it accurately. I wonder if I can erase that one. Dope. But yeah, it'll look something like that. Now in between here and here we have a negative slope. We're going down and our steepest spot is somewhere in the middle, so we're just doing some sort of down hump thing. We're going up between 0 and 2, so I'm doing some sort of up thing. Oops. And then we're going down between 2 and 3.5, so we have another little down part there. And then we're going up from 3.5 on, and so we end up like that, and it looks something like that. Alright, time to go check back with the chat. We're going to retake on Thursday anyways. Yeah, for everything but the trick. Do we have to retake the graph section if we only miss the hole? No, no, no. No, I'm not going to do that. That's mean. How do you know where to place the derivative lines and stuff on the graph? By looking at the slope of the graph. So like specifically for the piecewise ones, I'm like estimating in the like 9.2 the first set. Oh, these were both 9.2. That was sloppy. How many graphing derivatives? Probably one. Probably one. Those graphing derivatives multiple choice questions take up a ton of space because you have to have like derivative answers that are multiple choice. So yeah, one is how many of these will end up on the test. So whatever its slope is, that's the y-coordinate. Absolutely. That's it. All right. So more examples, please. Yeah, I do have some. I want to finish the quiz. Is the review guide what's going to be on the test? Since it seems like it was mostly new stuff like chain. Yes, yeah, it's mostly new stuff. I just did a breakdown of the test, and there's like 4 chain rule, 2 product rule, 2 like derivative on tangent line sort of things, 2 limit there's actually like 3 limit definition ones. There's some intermediate value theorem, all that stuff. Why is the sketch derivative of a parabola straight? Because parabolas are like x squareds, and the derivative of x squared is 2x, and 2x is a line. So that's why we end up having straight lines for the derivative of parabolas. Yeah, I was running through all that crap. There's a few trig derivatives on it. I'm going to be replacing some questions. I haven't actually like finished writing it, but that's what tomorrow's for. I got 2 preps. So yeah. Alright, I'm going to move back. I'm just going to do one of the trig sections. They may have been the same, actually. No, they were a little different. Because the trig stuff is really just memorizing the rule. So let me get both of these on here. Alright, so cotangent is cosecant squared x plus 1. But because it's it's negative. 5 sine goes to 5 cosine x minus 2. 7 cosecant goes to negative 7 cosecant x cotangent x. Cosine goes to a negative sine. Anytime we have a it's negative. And some people forgot to take a derivative of the 2x. That feels bad. That's why I ignored the minus 13, and I'm going to ignore the plus 12 here. It's because their derivative is 0. We have 3 secant x tangent x for secant's derivative, and 1 plus secant squared of x minus 5. I gotta say, I was really happy this year that fewer people were misapplying the parentheses, like not including the x plus 1 in their derivative, or the x minus 2, or the x minus 5. I've seen a lot more of that in years past, so I thought people did pretty well on that this year. Alright, so the bottom one kind of threw people for a loop. I'm going to do a new screen sketch, so let's pull this up. Oh geez, it's already at the bottom. And a lot of folks, when they looked at this thing, they were like, cool, this is A and this is B, but the problem is these things aren't multiplied, they're subtracted, so that's not A. Let's erase that. That's not A. What is A is the x here. It's an x times of g of x minus 1, so they're both x things, and they're multiplied, and that's a product rule situation. So the derivative of f of x plus 1 is f prime of x plus 1. And the derivative of this is, I gotta do product rule. Derivative of the first times the second is g of x minus 1 minus x times g prime of x minus 1 for the first thing times the derivative of the second. Then a lot of people did some other kind of mystifying-ish stuff by like plugging in the numbers and then adding 1, but this is f of x plus 1, so that's like f of 3, or f prime of 3 rather. So I just go to f prime of 3, that's negative 2. I go to g of x minus 1, 2 minus 1, g of 1, that's 1. And x is 2, and g prime of x minus 1, that's g prime of 1, that's 4. So this is negative 2 minus 1 minus 8, which is negative 11. The one on the right was a lot easier. It was just bottom d top minus top d bottom over the bottom squared. So negative 2 sine x minus top d bottom all over the bottom squared. And a lot of people, a fair number of people, when they squared x minus 1 cubed, got x minus 1 to the 5th by adding the powers. You got to multiply them. It's the third power raised to the second power, so you multiply their powers. Let's go back and check and see how we're doing. Can you explain how you got the A and B on 11.1 again? Really, that's the only comment. Wow. All right. Yeah. So the A, the A and B come from where something is multiplied, where x terms are multiplied. The f of x plus 1 isn't multiplied by anything, but the x and the g of x minus 1 are multiplied, and so that's where I have to do the product rule. And so I'm going to do the one on the other quiz, on the A version of this quiz, so that I can do this again. Yay. All right. Dun, dun. All right. So in this one, I multiplied x by f of x plus 1, so wow, huge difference between these quizzes. So here our A and B were the two things that were multiplied, which were in the first term instead of in the second term. And so this guy is just going to be, we're going to take the derivative of this like it's normal. So AB prime is x times f prime of x plus 1. And A prime is 1, so B f of x plus 1. And we're subtracting g prime of x minus 1. And now I just plug in 2. I get 2 times, what is f prime of 3? F prime of 3 is negative 2. Plus f of x plus 1, that's f of 3, that's 2. Minus g prime of 1. G prime of 1 is 4. So this is negative 4 plus 2 minus 4. That's negative 6, which is the answer to that guy. And this quotient rule was almost exactly the same as the one on the other version. I was pretty lazy with the variance this time, or the variability. So it's bottom, d top, So 2 cosine of x minus top d bottom over the bottom squared. And again, most people got this right, just some mistakes like squaring it and getting to the fourth, or like thinking you can cancel out all of the x plus 1s when you can't. You at least have to keep one of the x plus 1s on top. Yeah, so those were them quizzes. $11.1 is trickery. Alright, so Andrina's like, you went over the table, we're good. Alright, that's good. Okay. So, now I need people to point me in a direction. I'm to that point where it's like, I know the review is probably a good place, but which problems in the review would be good ones to look at? Can I do more derivative graphs? That sounds like a good place to start. If people can give me like problems in the chat, I'll look at it in a minute, but I'm going to graph a few more derivatives. Number 4 in the review. All right. I think this has more derivatives. So these are the matching ones in class, but all of these have like simple sections I can just graph all of them of. I just wanted something with a bunch of pictures in it, so I could graph these. So, if I was to graph this thing here, I'd look and see small, oops, I'm not on Screen Sketch. Cool. If I was to graph this, this first A1, I would see that I have a small positive slope here and a steep positive slope here. Because it's positive, it's going up. But it's getting steeper and steeper and steeper with its positive slope. So the graph of the derivative is going to look a heck of a lot like the graph of the function. Because it's a derivative, it's probably going to be a little less steep, so maybe I should have drawn it a little better, but whatever. On this side, we have a really steep positive slope, but we're getting less and less steep. And so we start really steep, and we're getting less and less steep, and that's how we end up our derivative. So I can erase these little extra lines now, and booyah, I have a derivative graph. Looking at this parabola guy here, I can see I have a positive slope here. I go through 0, so I should always mark my zeros on the x-axis, because they're going to go through 0 slope. And then, because I start positive, because this is a parabola, I'm going to start up positive and linearly go down here. Now, what the slope is, I could do more math and figure out, but it's going to look something like a line. And weirdly enough, that's this graph. Wow, it matched. Alright, I'm going to zoom down to more of these. Somehow, some way. This guy here starts off with a really positive slope, but here we have a 0 slope, so I might as well mark off all these zeros. Now this positive slope indicates to me that I'm going to be going from positive to 0 at this point, because I started on this side as positive, and I go to 0. And then between here and here, I am negative, so I'm going to bounce down to a negative. I go back to increasing on this side, because my graph is going up, so I'm going to do a little up pump. And then at the end here, I am going down and getting more and more negative, and so it looks something like that. This one's really easy money, because this goes through like -1, 1, and 1, -1. So we know the slope is -1, so we just go to -1, and we make a flat line, because lines have constant slope. And instead of graphing this exponential, because it's kind of boring, let's go over here and graph this thing. This is more exciting. This thing starts off with a small positive slope and gets more and more positive. Cool, it looks something like itself. And over here it has a really negative downward slope, but we get less and less negative as we go along. So I start really steep negative, and I get less and less negative. And so this one was a lot like one of our quizzes. So for each of these problems, you should be looking at what's the slope at each of the points. If it's continuous, mark off all of its maxes and mins as zeros. It's a really useful skill, because then all you have to do is look and see, hey, it's positive on this side, it's negative on this side. Cool, it looks something like this. It makes it pretty easy to do that. If it's a line, you just mark off whatever the slope is, and that's what it is, constant the whole time. If it's a flat line, it's just at 0. And otherwise, you're just kind of approximating. You're making your best effort to make it look something like what the picture is. Let's see if that answered any questions. It's a Kennedy trickery test. Yeah, it's a little bit tricky. I mean, it's an AP test. Is the test we're taking an actual AP test or one that you write? I wrote it, so it's not an actual AP test. The AP test is not on just 2 chapters of our book, unfortunately. How do you know when you have to do more than one chain? Well, let's do some chain rule questions. 5 and 11, page 3, 4, 9, 5 and 11, 7, 6. So 4, 6, 7, and 9 look like the ones from the first pages. 4, 5, 6, 7, 8, 9? Did 8 make it? No. 4, 5, 6, 7, 9. Let's do important stuff. I get derivative sketching. Yeah, but a lot of people don't. I posted those quiz scores. The derivative sketching was a little sketch. Alright. So here's the review. Let's go to 5. Alright, so 5 has this insanely cool trick, which is basically, this question is mad easy if you just combine those things. So if I combine these two things that have exactly the same inside to be 2t squared plus 3t plus 3 to the 1.5, it's a heck of a lot easier. Because all I have to do is 1.5 times 2t squared plus 3t plus 3 to the 0.5 times the derivative of the inside, which is 4t plus 3. And because we're plugging in 0, this makes it incredibly nice. This is just 1.5 times 3 to the 0.5 times 3. So this is 4.5 times the square root of 3, which is answer B. Sweet. Otherwise, you could do the product rule and chain rule within each of the parts of the product rule, and that takes quite a bit longer, so that kind of sucks. Alright, I'm going to do 6 immediately after, and then I'll go back and look to see if I've actually answered people's questions. In 6, I have a horizontal asymptote, y equals 10. That immediately tells me a is 10. So I know it's 10x plus b over x, and then I'm going to look at the next pit. So it tells me there's a hole at x equals 1. For there to be a hole, I need to have x minus 1 over x minus 1. So I need an x minus 1 on the bottom. So I know a is 10 and c is negative 1. And all I have to do is figure out what b is going to be if I have 10 times x minus 1. So b is negative 10. So if I do a plus b plus c, it's 10 minus 1 minus 10, which is negative 1. And that's it. I can guarantee you there's going to be a question like this on our test. Because I have some continuity questions, and this is a really elegant kind of one to ask on a test, because I can see whether or not you know it, and it doesn't take up a lot of room. So I like those. I like not using a lot of paper. It's a weakness. Alright, let's see how we're doing. What's the important stuff, Hartford? Oh, rip. Alright, so I guess I'll just keep moving forward. It seems like people are okay with this. So going to 7. Oh good, one of these is on here. So I was working on the test right before this. I tried to make sure I do that so I can actually prepare people, and it it's good to have a question like velocity and position, because that'll probably be on the test. Alright, so this asks for the acceleration and gives you the position. So position's derivative is velocity, and velocity's derivative is acceleration. So this is a fancy way of this test asking you to take two derivatives. And so this is what I would characterize as a chain rule question, because we got to chain rule a few times. So our velocity equation is going to be 14, because I chain out a 7, cosine 70. And we have cosine's derivative and the minus sign, so it's going to become a plus 10 sine 2t. And I took up way too much room here. Alright, so for my acceleration equation, I just am going to chain out a 7 and 2 again. So 7 times 14 is 70 plus 28, 98. Cosine of... oh, rip. Cosine's derivative is not itself. Alright, so negative 98 sine of 70 plus 20 cosine of 2t. So the beautiful part about this is that I give t equals pi. What's beautiful about this is that pi, sine is 0. At 7 pi, sine is still 0. At any multiple of pi, sine is 0. So this term is 0. And this term, if we plug in pi, cosine of 2 pi, that's cosine of 0, basically. So it's 1. So we're adding 20. And so this is 0 plus 20, which is 20. So man, trig derivatives, chain rule, position, all in one question. And people say the review is easier than the test. That's ridiculous. $11 and $12 would be nice. Wait, how do you get B? Oh yeah, okay, we're good. Seems like Johanna explained it. I can go back and look at it real quick. In B, because it's... oh, I can't write on the screen. Here we go. Alright, because... A has to be 10. So I know I have 10x, and I know I have x minus 1 on the bottom. And I need it to be an x minus 1 over x minus 1 whole. And so I know it needs to be 10x minus 10, because if I factor out a 10, I get x minus 1. I can cancel those. That's where the horizontal asymptote comes from at infinity. But it's also where the whole comes from. If I cross out factor on top and bottom, that's a whole. And so that's why it needs to be negative 10. And 10 plus negative 10 minus 1 is negative 1. Getting a 4 question. Did I not go over 4? Oh, I didn't go over 4. 4 is very family friendly. Also reasonably likely to be on the tests, this sort of question. Okay, if you know the trig circle of life, sine x, cosine x, negative sine of x, negative cosine of x, and then back to sine x, then this is pretty family friendly. We're starting here. So we're going 1, 2, 3, 4, 5, 6, 7. We're going to end up at cosine of x. But, oops, that's not what the question's asking. The question's asking, what is it the same as? Well, any later derivative is just going to be, you subtract the largest multiple of 4 that goes into that, so 7 minus 4, because 4 is the largest multiple of 4 that goes in. That's 3, so it's going to be the same as the third derivative, which is what that means. This means 7th derivative, this means 3rd derivative, and they're at the same spot. We could even look at this and be like, the 1st derivative, 2nd derivative, 3rd derivative, this is where I ended up. Wow, it's that one. So that's 4. I think now I'm going to like 9 and 10 or something. Let's look. Somebody talked about these. 11 and 12. Alright, not 9 and 10. Let's go to 11 and 12. 11 is almost exactly our quiz question. Alright, need to get these stupid cursor out of here. All right. So for 11, we need to find the values of a and c that make the following function differentiable. So I need to plug pi in for x and set these two things equal. So I get a pi squared plus sine of pi, no, just equals. Sine of pi is 0, so I don't even need to write that part. If I plug pi in here, I get 2 pi minus c. Well, crud, one equation, two unknowns. And so most of the time on the quiz and stuff, the smart thing to do is to say, well, now I got to set the derivatives equal because it's differentiable. So I set the derivatives equal. 2 is the derivative of the bottom one, and 2ax, the derivative of x squared is 2x, and the a just comes along for the ride, plus cosine of x. It's the derivative of sine of x, and now I plug in pi, and I get that 2 equals 2 pi times a, and cosine of pi, that's -1, so that's -1. I add 1 to the other side, I get 3 equals 2 pi a. I divide by 2 pi, and I get a equals 3 over 2 pi. So that means I am one of these two. Or that one, I guess one of these three. So I got to go through and like figure out what c is, so I just plug 3 over 2 pi back in for a in my first equation, and I get 3 pi squared over 2 pi equals 2 pi minus c. Cool, it's all pi's and garbage. So 3 halves pi equals 2 pi minus c. I subtract 2 pi. I get that -1/2 pi equals -c. So c is 1/2 pi. And I'm feeling pretty good about the world. That's pi over 2. That's this guy. D. So set the functions equal at pi, where these meet. Set the derivatives equal. Usually in the derivatives, you'll be able to get rid of one of the variables. That's like how the problems are set up. And yeah. The reason why this is a good question is it makes you take the derivative when it's a differentiability problem. It's really similar to a few of our quiz questions, including one that people retook a lot this week and didn't get right. Shout out to Colton Wiggin as the only person to get it right this week. Yeah. Nine, 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 nine. All right. Where did the 4 come from? Where did 4 come from? What? I'm so confused. Which question? Oh gosh. Well, okay, I'm gonna go do 9 because I got spammed with like 3 9s, and I don't know if somebody could tell me where's the. Oh, where's the 4 from in the derivative one? Yeah, and Johanna answered the question really well there. So trust Johanna. All right. Question 9. Dylan earlier asked, when do we use the chain rule multiple times? Here. This is where. The reason why this is a spot is because we have 2 insides. We first have 4 times something squared. Then we have sine of something. Then we have 3x. That's 2 chain rules. I got to do the outside thing. Then I got to do the inside layers. So I pull down the 2, and I get 8 times sine of 3x. And then I got to chain the sine. So the sine is my next inside piece. I get cosine of 3x. Then I got to chain this inside. 3 is the derivative of 3x. And so this is 24 sine 3x cosine 3x, which is that one. So yeah, when we use multiple chain rules is when we have multiple insides. Here there's one inside, but there's a second inside our trig function. Yeah, and that's why that is the way it is. Let's head back to the chat. Johanna do a live stream. Yeah, thanks for answering my questions, Johanna. Oh, 9 on the second part of the test. Okay. All right, Abby wants 12, and Ben asked for it earlier, I think. So let's do the 12 here, just to do one more practice that's like the that quiz, the product rule quiz. So this one has a product right here, x times f of x. So I get derivative of the first times the second is just f of x, plus the first thing times the derivative of the second. Cool, I got my product rule out of the way, and then I get minus g of 3x minus 2. Oh geez, this has chain rule thrown in here, because I have to chain out the 3 on the inside. Well, that was a good question. So anyways, now we plug in 2 for x. F of 2 is 5. X is 2. F prime of 2 is 1. And g of 2, or wait, 4? G of 4. 3 times 2 is 6, minus 2 is 4. All right. G of 4 is negative 3 times 3. So this is 5 plus 2 is 7 plus 9. This makes me a sad panda. Why did I get an answer that's not here? Well, whatever. I got 16. Maybe somebody in my chat will tell me why I did this wrong, but I don't think I did. Oh, because I'm an idiot. It's g prime. Okay, now I'm actually a legit idiot. All right, so the derivative, I actually have to take the derivative of this. And funnily enough, that was a mistake a lot of people made on the quiz, was they did this part right and then didn't take the derivative of g like I just did. So g prime of 4 is negative 1. So this isn't a 9, this is 7 plus 3. That's 10, which is one of our answers. It's B. Very professional work on my part here. So that's 12 there. And now I'm going to go to the 9 in the second part, which has been a very popular request. Kennedy played himself. Yeah, true. All right. Oh, use the product rule. Seems like fun. All right, can I zoom in on this? Oh, yeah. All right. All right, so use the product rule to differentiate this garbage. Cool. The derivative of the first times the second. 1/2 s to the negative 1/2. That's a prime times b. That's an s and a 5. Oh, goodness, this is dangerous. All right. And then minus the first thing times the derivative of the second. That's negative 5s to the 4th. Sick? I don't really see any reason to go beyond this here. It's not there's no prompt to do so. Looks fine. Hopefully that's what people wanted. 7, 8, 12, 15, 22, 23. All right, word. Yo, your answer is wrong. Your answer key. Oh, yeah, whatever. I mean, it happens to the best of us. That's why that one was asked for. That makes sense. Hey, good work, you guys. You're smart. All right. So 7 and 8. Sure. Oh, good. One of these questions is on the review. Cool. Determine the points, if any, at which the graph of the function has a horizontal tangent. What this tells you, horizontal tangent, is that the slope is 0. So all we're doing is taking the derivative and figuring out where it's 0. So y prime of x equals 3x squared plus 12x. To find where the thing's 0, I'm going to factor out a 3x, because that goes into both of them, and I get x plus 4. And so x equals 0 and x equals negative 4 are the 2 points that make my slope 0. So you're just taking the derivative and finding the zeros. Yeah. It's mostly vocab. Do you know what a horizontal tangent is? There's a decent amount of what makes the AP test hard is the vocab. So a lot of people kind of like rage a little bit about how much vocab I end up putting on a lot of the earlier quizzes, like the power rule one. But a lot of that vocab is the same stuff that makes people bomb tests. So I feel vindicated in putting it there. That's the wrong word. Whatever. All right, 8. We have a ball thrown out from the top of a 250-foot building. They actually like threw it downwards because it starts with a negative 12 feet per second velocity. What is its velocity after 3 seconds? Well, luckily, they give you this beautiful equation here. So our equation is that s of t equals negative 16t squared minus 12t, because our initial velocity is negative 12. And our height of the building is 250. So I just plugged in the stuff I was given into the problem in for starting velocity, starting position. Alright, so now I just take the derivative of this. V of t equals negative 32t minus 12. And to find the velocity, I just plug 3 in. That's my velocity equation. So negative 96 minus 12 is negative 108. Sweet. What is its velocity after falling 150 feet? Well, this requires some janky math, I'm pretty sure. I'll give my best effort here to solve this. Alright, so basically 150 is s of t. It's, after falling 150 feet, I subtract 150 from 250, get 100, that's my s of t. So I get 100 equals, oh, I'm going to go off the screen. I need to erase some garbage. Oh, I just erased my good equation. Well, whatever. Alright, so 100 needs to be equal to this equation that is my position equation, and I need to find t. So I get that negative 150 equals negative 16t squared minus 12t, and then I'm like, crap, there's t's in both spots, and what we always do in this situation is we actually want it equal to 0, so we get 0 equals negative 16t squared minus 12t plus 150. And then you quadratic formula / this would definitely be a calculator allowed question because you can just graph this on your calculator and look at where t goes through 0. That's absolutely how I would do it. And so t is like some garbage, and then you just plug this into that velocity equation and you get your answer. Where our velocity equation was negative 32t squared minus 12. Or sorry, whoops, negative 32t minus 12. You just plug whatever some garbage is in for t there and find that value. Sorry for the lack of follow through there. Alright, what was my next question? Your answer key is wrong again. Rip. Alright. Will physics trickery questions be on the test? Yes. Yes. Alright. To the more of Nicole's list, since she's very organized. 12 and 15. Alright, so 12 is a mess. Looks wonderful. So 12, we have the lovely situation where we have a product rule and a quotient rule, unless we distribute the v right away, which I am definitely going to do. So I can write this equation as 7v minus 5v over v plus 2. And now I just have an easy derivative and a quotient rule. So I get 7 minus, and now I have quotient rule. So bottom d top minus top d bottom over the bottom squared. And I'm hunky-dory happy. This is great. This is the answer for 12. That's it. Pretty easy. If you distribute. If you product rule it, the answer is a lot longer. So that's kind of sad. Is 8 going to be on the test? A question like that could definitely be on the test, yeah. Physics trickery is going to haunt me on Halloween. Yeah, true. Everything on this test that you don't know is going to haunt you. Alright, 15. Find an equation of the tangent line to the graph of f. Alright, sounds good. So this is good because it kind of reviews the vocabulary that often trips people out. Find an equation of the tangent line. Step 1, find the slope of the tangent line. So find slope. So we have this equation. Now we could do product rule, and it's kind of debatably easier to do the product rule or just to multiply it out and then find the derivative. So for giggles, I'm going to go ahead and do the product rule. I was super tempted to just distribute, but whatever. So derivative of the first times the second is just the second. Plus the first thing times the derivative of the second. Yeah, it's really not bad at all. So my derivative is 2x squared plus x squared, that's 3x squared, minus 8x minus 5. Which you probably could have gotten just as easily by multiplying this first, but whatever. So I plug in 2, because that's what x is, and I get 12 minus 16 minus 5. So my slope is negative 4 minus 5 is negative 9. Now what I need to do is I need to actually just plug this in. All right, so this is easier than I thought. Point slope form is your homie here. Y minus y1 equals slope times x minus x1. Sick. Done. Remember, x1 and y1 are the point that we're given. Oh my gosh, point slope form is by far the best way to write equations in general in this class, because so often we solve for the slope with the derivative and we're given a point to plug in the derivative, so point slope just makes sense logically. Okay, cool. Do we get calculators on the test? Yes, for like, I don't know, 8 of the questions, and like for 17 you don't. It's usually about 2/3, 1/3 on the calculator. Why don't you say v prime blah? Is the test cumulative? Yes. There are a few limits on there. If you remember anything of limits, you should be alright. I think the limits questions are pretty easy. There will be definitely continuity questions. There will be limits at infinity, limits at 0. Honestly, on every AP test, there's questions that are like those on the AP tests. How am I doing? 22 and 23 were the other ones on the list. Everything is easy for you. I don't know who that's to. Alright. Oh gosh, 22 is a disaster. Alright, 22 is a calculator problem, so let's talk about what you'd do. Because look at that awful point they give you. Wow. So it says, find an equation to the tangent line to the graph of f at the given point. Alright, so we take the derivative. F prime of x equals, and this is our good old hidden chains problem. This is tangent of x to the 6th. So we get 6 times tangent of x to the 5th times the derivative of the inside, which is secant squared x. And then you're just going to plug 3 pi over 5 in for x in both of these spots, here and here. And figure out what those are, and then do y minus y1 equals whatever that answer is when you plug 3 pi over 5 in there, times x minus x1, which is 3 pi over 5. And that would be your equation. Seriously, point slope is your homie. And if the answer is written in slope intercept, just solve the point slope equation. It's pretty easy stuff. It's pretty nice. 23, find the second derivative of the function. This is going to be a mess, and this is a good mess to practice before the test, because I know this kind of questions on the test. I actually added this to the review this year, so it wasn't in the answer key, so that's probably why I got asked about it. Anyways, this question. If we take the derivative of sine, we get cosine. So cosine of 3x to the 5th times the derivative of the inside is 15 times x to the 4th. But now for our second derivative, we have a product that we created by doing the chain rule. So that sucks. So our second derivative is going to be a product rule question with a chain rule question. So derivative of the first is negative sine of 3x to the 5th times the derivative of the inside, which is 15x to the 4th, times b, so this is a prime, times b is 15x to the 4th. And now I'm adding a b prime. So a is cosine of 3x to the 5th. And b prime is 60... 60x cubed. And this nonsense, that's the answer. So on the test, it would look something like negative 225x to the 8th sine 3x to the 5th, combining up all the like terms, plus 60x cubed cosine 3x to the 5th. And yeah, these are great questions because I get to test product rule and chain rule within the same question because you got to do both. So pretty cool kind of question. All right, let's see how I'm doing on my questions. Degree 22 is a hot mess, yeah? 65% and up is an A, yes. And like 55% and up is a B. It's probably more like 70% and up is an A, because these are out of 4, so people are going to do quite a bit better. How did I get the second 15x to the 4th? I got it because I had the first 15x to the 4th was from the chain rule, and the second 15x to the 4th was B. The A prime, the first 15x to the 4th was in A prime because I had to take the derivative of the trig function again, and the second one was from the B, just the second term in the product rule. On number 7, in the first part, why did you take the second derivative of the particle position equation instead of just doing the first derivative? 7 on the first part. So you don't expect us to do well. Well, people kind of do crappier on multiple choice tests in general. So yes, I don't expect to do that well. But I do expect that our class averages are going to be in the high 50%, which will be in the, like, I don't know, low to mid B range. That's kind of what I'm expecting on this. Let's see where we're at question-wise. We're doing all right. So 7 on the first part is Joanna's question. Why the heck are we going to suck so much worse? Multiple choice is brutal, man. Like, you can just make one little mistake, and if the answer's there for you, you just get shreked because you select it. Or a lot of people have, like, bad multiple choice techniques, and so they kind of pick the answer that's closest to the answer they got. And Johanna, I took the second derivative because I started with position, and I needed to get to acceleration. And so, to look at this, because a lot of people are like, oh, physics rip. If you start with position, one derivative down is velocity, which is x prime of t. And then one derivative down from there is the second derivative of t, of x rather, which is v prime of t, which is acceleration. So it's why in the power rule notes stuff, there was... whoa, why is there an A prime? That's wrong. It's A of t. That's why I made such a big deal out of this being a thing. We're going to practice it a ton more next unit. I can guarantee there's only going to be 1 or 2 problems like this on the actual test, so it shouldn't be too bad. You just need to remember velocity is the derivative of position, and acceleration is the derivative of velocity. Retakes on the last quiz. Let's see. We haven't gotten to the derivative stuff in physics. Yeah, you never will, because we don't have calculus-based physics at this school. So one thing I wanted to bring up that I can say is on the test, but I'm not sure was in the review. So I wanted to review the intermediate value theorem on here, because we talked about that a little while back, but we maybe haven't looked at it in a bit, so I have the notes here. And I wanted to go down to intermediate value theorem. So here in our notes, it says the intermediate value theorem says that when you connect 2 points with a continuous function, it must pass through all the y values between those 2 points. This shows up a hilariously large amount on the actual AP test. So many of our sample questions that fit in the first 2 units requires some execution of the intermediate value theorem. So to give you an example of what one of these questions looks like, I'm just going to go to the random sketchpad where I have hi written. Oh no, I don't need a ruler. So how this looks is they're going to give you a function. They're going to say, hey, A is 1, 1. They're going to say B is 3, 80. And they're going to basically give you a whole bunch of garbage multiple choice options that say like, oh, the slope needs to be positive everywhere. Which is not true. Because it could go down and then go back up to 3, 80 if its vertex is at 2 or something. They're going to give you ones like, it needs to be 100 at some point. No, it doesn't. 100 is not between 1 and 80. And then they're going to give you the good one. It needs to be 75. That's between 1 and 80. And so you're like, heck yes, I pick that one. That's what intermediate value theorems look like. They're like, dude, this thing's continuous. It goes between these 2 points. Which of these has to be true? And you need to know that every one that isn't, it's one of the y values in between, is not the intermediate value theorem. So I just wanted to review that because as I was looking through the tests, I originally had 2 questions like that. I'm probably going to pull one of them. I already made a note to myself that I'm going to put another trig derivative question on there because there were only a few. And people are pretty good at that. I know from the quiz people got like 90% average on, and that's easy to study for a test. So I'm going to put that on there instead of one of those. But just know that this sort of thing's coming. The AP test loves to ask questions like this. Calculus students need to know physics. Yeah, kinda, honestly. Feels bad. Can I get through triple chains? Yeah, I can. I don't really want to, but yeah. Okay. Wait, it's 8. It's my bedtime. Kind of. I'll do 1 triple chains, and then I'm gonna call it an evening. What isn't easy to study for on this test? Anything that's execution based. So okay, so vocab is a huge one that usually destroys people on this test and other tests. So there's stuff like you need to know tangent, you need to know normal, you need to know secant, you need to know what are other big vocab words? Differentiable, continuous, you need to know infinite discontinuity, all that sort of stuff. That's like the hard one. Who goes to bed at 8? You know, come on, man. I'm not gonna go to bed. I just want to like play video games or something. Give me a break. What's normal? Not me. No. Normal lines. So tangent line. Let's go back to the sketchpad. It's much easier in the sketchpad. So if I have some sort of curve and I have a point that I'm evaluating the curve at, and I have a tangent, it's going to look something like this. Tangents are easy. Tangents just have the same slope as the graph and only touch it once. A normal line is just our curve way of saying perpendicular. So if for our tangent line, if we were to find a normal line, all we would do is do the inverse reciprocal. If this is a slope of, say, -1/2, this guy would have a slope of 2, and then we just use the exact same point to find its x1 and y1 for the point slope form. And that's it. So normal is perpendicular to a curve, kind of, because it's hard to be perpendicular to a curve, but it's perpendicular to the tangent line to the curve at that point. Any other questions? So velocity is the derivative of position, acceleration is the derivative of velocity. Nailed it. So vocab and physics. Yeah. Yes. Vocab is the ultimate killer. Just wait till we get to free response questions, because you have to understand what they're saying to answer them. Alright, I wanted to make sure I did a triple chains, because somebody asked for that, and they want me to struggle, because triple chains are brutal. So our most classic example of a triple chains question is going to involve some sort of sign, maybe to the 4th power, and then we have another chain within here. So like the cosine of x squared. This is a pretty simple sort of, I have no idea how many chains I made here. I think I made 3. Let's try it out. So first of all, I have something to the 4th power. So I get 4 times something to the 3rd power. And that's my first part. Now chain number 1, I have to take the derivative of sine. So that's cosine of x squared. Close parenthesis. Then the derivative of cosine is negative sine of x squared. And then my third chain is the derivative of x squared, which is 2x. So original function, chain 1, chain 2, chain 3. And that's 3 chains. Look how simple this thing was, and look at how awful its derivative is. Welcome to calculus. Ugh. We can't see it. Ugh, crap. Oh, that feels bad. Well, I can show it now. I think I was talking to... Oh, I did it at the top of the page like a freaking scrub. I am so sorry. That was really bad. Can I, like, move this now? Oh, jeez. And then I'm also too much of an idiot to figure out how to move it onto the screen, so that feels really bad. No, I don't want to share that. I'm so sorry. Hey, I'll do that again! So you get extra time, and I talked through some garbage. Alright, so now let's put this on a screen people can see. So I did sine of cosine, sine to the 4th of cosine of x squared. That was the problem I did. So the derivative is 4 times sine cubed of cosine of x squared, because I take the derivative of something to the 4th. Remember, you can always rewrite this as this whole thing to the 4th, which kind of tips you off that you're going to have a crap ton of chains here. Our next chain is going to be of sine, so we get cosine of x squared. Our next chain is of cosine, so that's negative sine of x squared. And our last chain is of x squared, that's 2x, and hunky-dory, that be the answer, and hopefully it was visible this time. And sorry about making it not visible. That was a rookie mistake. But yeah, that's 3 chains. That's original problem, derivative, chain 1, chain 2, chain 3. Sweet. I second that, Hartford. It's okay, just don't put it on the test. How do you get cosine of cosine? I take the derivative of sine. So the first thing I take the derivative of is something to the 4th, then sine, then cosine, then x squared. So that's why it's 4 sine, then derivative of sine is cosine, then derivative of cosine is negative sine, then derivative of x squared is 2x. Hopefully I answered your question. We're starting to lose people like flies now. I feel like this is the end. So, folks, it's been real. I will see some of you on Tuesday. Hopefully all of you. We'll see. And we'll take this lovely test. Good luck. Get some sleep. Have a nice weekend. All that kind of stuff. And yeah, you totally keep digging deeper. Yep. Have a nice weekend, y'all. You know, play some video games for me.